test methods to testing practitioners, which is the certificate, the ICEP ICQB certification books. You have books on Agile, you have books on test process improvement methods. So a lot of going on only in the Netherlands, and I suppose if we would add all the international books, we could not see a white on this slide anymore. And with the story that Bob and myself are going to tell you today, maybe in 2010 something like lean test management might be added to this whole bunch of test ideas and test improvements. First, a bit of history on Lean and Six Sigma, because that's where we got the ideas from. Lean started off with Toyota production systems, and they try to look at their process, try to make it quicker, try to make it more efficient. And they do that, or the Lean method does that by following 7 ways. And here you see the 7 ways as Toyota defines them. And I suppose there's maybe when you look at them, not all of them straight away get you an idea that might be related to testers straight away, but I'm sure you see a few that you think are probably, we can relate to them in testing as well. Look, for example, at the second one, weighting, which means, as you can see, it actually, because it comes from Toyota, these terms are probably more related to logistics and actually making products. But weighting is also an important subject in testing. How often do we have to weight in our process at whatever stage? At the start we might not have the functional designs that we need. When we want to start executing the test, we might not have a test environment. So you look at parts in your process with regard to weighting, and you try whether you can actually eliminate this waste. So how can I get more efficient? How can it be quicker? Transporting as another example. Which parties are involved in giving us as a tester the information? How do requirements or functional designs or technical designs eventually come to us as testers? How efficient is that process? Think of, for example, unnecessary inventory. We're creating test cases for release X that we're working on at this moment in time. And we try to make it very efficient and everyone can look at it, and we're doing a good effort in trying to reuse it another time, but because the company we're working in doesn't have a proper version control, it just ends up somewhere on the shelf, and next time we have to do 80% of what we've done, we have to do it again. So we're creating unnecessary inventory. How can we make that better so our test process is quicker and more efficient? Well, I suppose the last one, defects, is pretty clear. We want to eliminate defects. That's what we're for, probably as testers as well. So I think from Lean, there's a lot of ways that we can also learn from, and we can improve our test process. And of course, Lean comes with all type of techniques and tools so you can look at overproduction or weighting or transporting. How do you eliminate those wastes? Well, we're going to look at that later on in the part that Bob is talking about to also show you a few of those techniques. Well, let's look at Six Sigma. I suppose that's also interesting from a testing perspective. Is Lean looking at quicker and more efficient? Six Sigma is looking at the quality and how you make things smarter, how you look at it in a smarter way. Well, another subject that we can relate to in testing, time, money from Lean and quality from Six Sigma. Well, 4 key elements in Six Sigma are delight the customer, improve your processes, teamwork, and data and facts. I suppose the same as with the 7 ways from Toyota, also here we can see subjects that we can relate to in testing. Delight the customer. Is that not what we want, or is that not what we're aiming for as well? If you look at risk-based testing, for example, where are the biggest risks that our customers see? So if we're looking from a Six Sigma point of view, we're also looking at the customer. That's the person or the group of people where we're actually testing for. So we want to involve them more. We want to improve processes. That's what we're doing a lot of the time. We try to make our test process more efficient. We can go to lean in that respect. Teamwork, also something we as testers are looking for all the time. It's not just us as a test group with a test manager. We want to involve more people because we need other people to actually make the testing better, make testing more predictable. It's not just us. We need the customer, we need maintenance departments, we need developers, we need all other people. And data and facts is a very important element in Six Sigma. And I suppose over the years we heard on various seminars a lot of metrics, and we can improve our test processes by also keeping metrics and do something with them. But also an important subject in Six Sigma. So we're going to look at that later on as well. But I think when you just look at this slide, you see a lot of subjects in Lean and Six Sigma that are easily that you can easily relate to testing. And that's what I try to do even a step further. Look at a few subjects for Lean, Six Sigma and test management and see how easy you can combine them. And I'm very thankful to Mr. Thomas Burgt, because I found in an article that he wrote where he already combined Lean and Six Sigma, so I just had to add test management in that respect. If you look at the goal, for example, for Lean, you see again that eliminate waste. You want to create a flow, you want to make your process more efficient. In Six Sigma, you again see the word improve process. You want to eliminate variation, which is variation is the difference from the average. You want to be more predictable in what you do. In test management, what we want to do is manage the test process. We want to see what the quality actually is, and we all want to do that within time and budget. Well, within time and budget means, in a lot of cases, we have to be more predictable. So we want to eliminate variation. We want to eliminate waste, because otherwise we would never be able to manage the test process within the set requirements. Where is Lean used, the application? Well, you see that a lot in manufacturing processes. The quality Six Sigma, you might see it everywhere. And testing, I think we do testing everywhere as well in all business processes. For the approach, best practice on with Lean, called a cookbook style. You tell people how they do it. You take them step by step. Six Sigma is a more mathematical approach, I suppose, if you read into it, very much based on statistics. And I think for testing or test management, we use a bit of everything. We use the cookbook style because we have certificates that we can all have by following. We learn about test methods. We follow them step by step. What do we have to do to eventually get the result that we want? But we also look at best practices, and we try to look more and more at metrics. So again, test management has something from Lean in this respect and something from Six Sigma as well. How are we looking at the projects? You see a technique at Lean, the value stream map, and Bob will show you an example of that later on, which is one of the most important techniques in Lean. And well, I hope that you see it well when Bob talks you through the value stream map later on. And you see it's actually a very valuable tool for testing as well. In Six Sigma, you can use various approaches, and in test management, we look a lot at product risk. So here we see some differences, but again, we can relate to it. And the second part of this comparing Lean, Six Sigma and test management, the length of the projects, well, they can vary a bit between Lean and Six Sigma and test management. But the infrastructure, I think there we see the the biggest alignment with Six Sigma. We're working preferably with dedicated resources, broad-based training, but maybe there are still some projects that relate more to Lean, where you have ad hoc or little formal training. And a lot of learning by doing. With all the certificates that we have, there's also a lot of learning by doing in the three of them. So just looking from a very theoretical approach, I think, or we think, I should say, Bob and myself think that Lean and Six Sigma are very well, are very good techniques that we can use, or we can at least take in the back of our heads when we're looking at our test process or test management processes. I'm going to give now word to Bob, and he's going to give you a bit more in-depth on various techniques that we picked from Lean and Six Sigma, and we're going to use in combination with test management.
Thank you, Iris. Well, the roadmap to Lean test management. We picked a couple of techniques. There are many more. You can look at more techniques on our tutorial at EuroSTAR. The basis for the roadmap is the DMIAIC cycle. You can compare it a little bit with the Deming cycle to improve processes, but in Six Sigma there's more emphasis on measurement and analysis, because that's the only way to really improve the process. Because if you don't measure, how do you make certain that you succeed in improving your processes? Between every phase in that cycle there's a toll gate. At the toll gate you will validate the business case for the improvement. So that's a lot like Prince 2. In each stage there you validate the business case as well. Should we go on or do something else? I think it's very wise to do it like that. First we go to the step define. The purpose of this step is to define which project we should undertake for our improvement. And the best thing to do that is to do this with all the team members that are going to be involved. For a project you make a project charter, and well, everybody is involved to have input for that. So they're also keen to get results. If you think of a project yourself and you say to the team, just do this, well, there's less involvement, and involvement is a key success factor for us. So you make that with your team. There are various tools you can use to define the project. What's important when you want to improve your processes is to have a clear view on the current process. So you can use CPOC diagrams and value stream map for that. We'll first have a look at CPOC. In CPOC, the middle letter is the P, that's your own process. We've created a little example for the test process. We define the test cases, design the test data, we configure a test environment, and then we execute the test cases. In order to carry out our own process, we need some input, and we need to get that from suppliers. So now you can see where the letters stand for. It's supplier, input, process, and later on you see output and customers, because we're creating our results for somebody else. In the inputs you see our test basis, and we will get that from functional design or technical design and architects. And we need company architecture. All these we need as input for our own process. On the output side, well, we hope to have some correct outcomes, because then the product we are testing is quite good. We might have some issues we need to attend to, and we create a test report. For whom we do that? For the customers. There are stakeholders, the help desk, the project managers, but we can think of a lot more stakeholders as well. The good thing when you apply this, you have a high-level overview of your own process, but you can connect it with other processes in the organization, and you can see whether it connects or not. There might be some things we need as input, but the other party doesn't know in which format to deliver it, so we can use it. We can say in our process design test cases that we use different test techniques, But if the functional design isn't good enough to apply these test techniques, it doesn't make sense, and we can't deliver quality as well. So it's very important to discuss these processes with all the other stakeholders in the organization that carry out the other processes. Well, I carried this out in one of my projects, and at this moment all departments at the client sites want those CPOX diagrams because they can communicate better and not only focus on the whole process. So there's a lot to gain there. Well, now we have a high-level view of our process. Yeah, who is the supplier, who delivers, what input is delivered, what's our process, what comes out of our process, and what's the customer. But we need a better view of the process itself and see where there's some waste we can ban, because that's the reason we are doing this. Well, we saw that we need a test basis and a company architecture as an input for our own process. It's probably sent to the test manager, and in this diagram he will take 1 hour to process. So he's adding value for 1 hour. And that's important because in Lean Six Sigma it's about adding value for the customer, and we want to ban wasting time. When the test manager is finished, the test analyst can start designing test cases, and he will take 10 days for that. But you see the triangle in front of the picture of the test analyst. There's a 1 day waiting time. That doesn't necessarily mean the test analyst is doing nothing. He needs to have an excuse for that. It could be that he still has work in progress from another functional design or something. Input is also sent to the test engineer, also waiting 1 day before he is doing his job, setting up the test environment, and that will take 5 days. The time that those people are adding value to the project doesn't mean that they're doing that in an efficient way. This is just an indication that now it's taking 10 days to design the test cases. But maybe with different techniques, it could be done in 7 days. So it still needs further investigation, but this gives you a first idea of how the process is going and how much time we're adding value and how much time we are waiting. When this is done, we can design the test data. There you see it's taking the test analyst 5 days, half day waiting time, and then halfway waiting time before we can execute it, and the execution will take 14 days. Now it's important to look at those triangles, because half a day waiting time doesn't necessarily mean that that's bad. Before test execution, maybe that half a day is when we got the test environment. But if there's a 10-day waiting for a test environment, that is something to investigate further, because that's clearly an area we can improve and ban waste. If from some designs we take more time to design test cases than others, we need to look at the designs and see if we can improve there, so it's all done in the same way, and we can improve on efficiency in adding value within the task. So this is a very important and simple instrument to look at potential projects we can undertake to improve our process. Once we have picked our projects based on this, it's important to see what we're dealing with. So we need to measure. So maybe there are existing measurements in the organization, so investigate that. See if those metrics make sense as well, because nothing is worse than improving your process based on the wrong metrics. Closely observe the process. You can use your value stream map for that. Gather data and map the process in more depth. It's important when you have some ideas about the project that you use simple tools again to measure. One example is the Pareto chart. Pareto is an Italian economist. You might know him from the 80-20 percentage rule, and that's what we use in this technique as well. We might have a lot of waiting hours in testing, and we can measure 100 times and see what the cause was of the problem. And here you see failures in the test environment in 65 of the cases, failures in test data, 20 cases. So what we can do here is we draw a chart that makes it visible where the main problems are. And we divide the columns and we go from high to low. And what you see is most of the times when you take the first two columns, that you are above the 80% of the causes of the problem. So it makes sense to focus your improvement effort on those first two. So this makes it easier to choose which improvements you do first. Once you have the measurements, it's important to analyze. So we use the collected data to confirm the sources of delay, waste and poor quality. And there are, again, some tools we can use. They're very simple. The 5 whys and the Ishikawa diagram. I will start with the 5 whys, because normally when you ask a question you get a pretty clear first answer, but when you are going to ask deeper you get to the real cause of the problem. So it's important to keep on questioning things. So for example, why are there long waiting hours for test execution? Well, the answer is because often there are failures in the test environment. Well, that's pretty clear. Go to these guys and say, well, don't have those problems anymore. But that's not a real solution, is it? So we have to go something deeper. So why are there failures in the test environment? And the answer might be, because we often seem to have the wrong version of the test objects. Aha! Where have you seen that before? Why do we often have the wrong version? Well, it's because someone installed the wrong version. Well, that makes sense. But they probably don't do that on purpose. Why does someone install the wrong version then? Because we don't have proper version control. Well, why not? Why don't we have proper version control? Because we never got around it. But it seems to do time to do it right now, especially when we saw in the Pareto chart the failures in the test environment are in 65% the cause of our waiting time. Well, that will cost a lot of money, so sure it makes sense to get proper version control now. So these simple techniques make it clear for the environment where we put focus on. Another technique is the Ishikawa diagram, also known as fishbone diagram, because it looks like a fishbone. On the head of the fishbone we put our problem, and then we can think of areas where the cause of the problem lies. So failures in the test data might be a quad database or all test data. Failures in the test cases, an unclear functional design, unclear requirements. Could be several causes for the problem. Well, creating this fishbone doesn't say what the problem is. Those are all possible causes, so you need to investigate further if it's really the cause of the problem. But then you can use this Ishikawa diagram as a checklist, so to check whether you have checked all possible causes. So if now we have look at the process, look at the problems, where are they, look at possible causes, well, that's the time to define which measurements we can take to improve the process. Well, we know a lot of existing improvement models in testing and outside testing, and this is where our theory about lean test management connects with test process improvement models like TMM and TPI. Because when we kind of look at things to improve the process, you can, based on the things you have found, you can pick the best things from those models and use it in the implementation of the improvement here. So you want to make changes in the process to eliminate defects, waste and costs, linked to the customer needs identified in the define phase. We took a couple of improvements from the models we already know, but you can also think of common sense things to improve, because some problems are rather obvious, and based on our experience we already know how to improve that. But where do we start to improve? We have several ideas. You can use the pick chart to pick the best ideas to start there. I have a little example of that. You can make a division between easy to implement and hard to implement. And you can look at large result and smart result. As you can imagine, when you put your ideas on this map, that the top left corner are the things that make us most happy at the start. They're easy to implement and we expect a large result, so we want to implement that right away. When we are in that bottom left corner, it's hard to implement, but still large results. Well, it will take some more time to implement, but that's okay as well. We can start us off. Small result, easy to implement. Well, a little less important, and if it's hard to implement and we expect a small result, well, don't even start with that, because your business case for doing that won't hold at the next quality gate. So when we implement those things, it's important that, and that's the last stage, we get control over our improvement. It's important that every improvement we make, that it lasts as well. So for that we need to keep measuring to see if we still have a process within the quality limits, and where there are measurements beyond those limits that we can take action. What's an important tool for that is the control chart. Well, this looks a little bit more difficult, but it is relatively easy to design, because there are simple mathematical formulas as the basis for that, and you can also use statistical applications that can easily do those measurements for you. Well, you see LTM, we say that is lean test management. Before we did that, we had an unpredictable process, so there's a lot of variation in our measurements. We have done some improvements, and you see the improved process, we have less variation, and that's good. We have a more predictable process. In the control stage, it's even better, and you also define an upper limit and a lower limit to your measurement, and those are the triggers for action. If we are above the upper limit, we should investigate right away what's going on and how we can get back within the limits. What you see on the top right corner are the sigma levels. There you see where sigma comes from. That's the variation in the quality of your process. When you look at sigma level 1, for instance, that's if you go to that level, you have a gain of about 30% in your process. Well, where does that relate to? You can say that 690,000 faults per million products. That could also mean 690,000 defects in 1 million lines of code. Well, that doesn't seem good, does it? When you look at level 5, for instance, that's one typing mistake in 10 books. If you go to level 6, that's one typing mistake in 3,000 books. So that's a very high level of quality. For some companies, that will cost a lot, and that's just a too high a level for the product we are making. But if it's safety critical, that might be the figure you are aiming for. When you start using this, most companies who look at what level they are at level 3. So that isn't that bad. That's 1.5 typing mistake per page you're writing. So I hope to have given you a little overview of some of the techniques of Lean and Six Sigma. There are hundreds of techniques within those theories, so this is only an example. And I will give the line back to Iris for the conclusions.
And here are the conclusions.
The final vote.
Of course, we hope that from this presentation, from the start, with a general overview, then from Bob's input for a little bit more detail on a few of the techniques that come from Lean and Six Sigma, we hope that you also got an idea that test management and the test processes we're working with can also benefit from these techniques. And as Bob said, we only picked a few that we think are simple enough to use. Bob gave an example. He used one at the customer side at this moment. I used one or two of the examples that Bob just gave, and they are actually easy enough to use. So we hope that from this presentation you also got an idea that you might get some ideas that you want to use a few of these techniques within your companies. I think the basic message, or one of the basic messages, is that Lean and Six Sigma are actually trying to improve from within your own company. You take the processes that you have at this moment in time and you see how the company is using them and where you can improve from your situation. While a lot of the test process improvement methods that we know, Bob already mentioned TMM and TPI, they're more like benchmark models, and you try to combine them with your company, but that might not always be one-on-one so easy to use straight away. So here you start with your own company, you see where you can improve, and of course you can, that's in the third bullet, of course you can pick parts from we call it standard test process improvement models, which of the parts that we can use within our company, but we're looking at it then mainly from us and what can we use from those models. And the last one is that you probably will get a better integration of your test process with other processes. Think of that CPOC example that Bob gave. You have to maybe look at other processes as well, and they have to be more part of the test process. Before I start answering the question, because I think I see two questions. Yes, thank you, Kevin. Of course, we like to have another idea. From this introduction on lean test management, you see a poll now on your screen. And of course, we like to know whether you think that lean test management actually will work in your organization. As people are voting, I see that the answer yes, but I will need some more information is voted most. I'm going to do a bit of
That's good, because you can come to our tutorial.
Yes. On Monday, the 29th of November, we host a tutorial at EuroSTAR, and then we, of course, will give you more information. This was the introduction. Thank you for the poll. I will look at the questions now. I don't think you can read the questions, so sorry. You can. It says, because I don't think everyone can read that, in the early diagram, you suggest that suppliers need to provide requirements. But what if they can't or don't know how to, or provide invalid information? How does it affect your metrics? Oh, I suppose I can go back to our own presentation. I have to go up a few slides then. I think the question goes with the CPOC example. We have to go through all of them. We're getting there, nearly there. This is the example you're talking about. Eventually, of course, it will affect your metrics, your outcome, if their functional designs, technical designs, or whatever they deliver, their requirements are not up to your standards. One of the benefits of both Lean and Six Sigma is that you you can't look at one part of a process and improve that, because that will not, the outcomes will probably not be positively affected if you only improve one part of your process. So what we mean with this example is that the outcome might be to improve your test process, so the P part of the CPOC might mean that also the suppliers have to improve part of their process. So they have to write this CPOC, they have to draw the CPOC diagram as well and see how their process look like, and they might also find then flaws in their process, or they might find parts that they have to change.
Yeah, and when you look at the value stream map, you see the time the test analyst takes to design the test cases. That might be a very high figure. That's 10 days now. Maybe it's 30 days because there were bad requirements. And when you look at the efficiency within that, you can address that and see if the organization can make some improvements in the process of developing the requirements. So with these techniques you can see that as well, and make the improvement broader than only the test process.
Yep, so we hope that question is answered. And there is another question, and I think we're exactly at the right slide now. The question is, could you please repeat the meaning of the triangle with 1 day wait? Okay, that is the time before, for example, the test engineer starts his work. He gets the company architecture or the test basis from the test manager, and 1 day after he got it, he starts working with the test basis or the company architecture, just whatever he needs. So it takes a day before the person actually starts using what he got for his job.
So what this means, the test engineer is taking 6 days to deliver his work, but there's only 5 days added value. So there's 1 day waste in the process.
Yeah. I think that were the. Is that no? That's not it. So I think that were all the. That was the final question. Then we'd like to thank you for listening to us, and well, we might see you on at EuroSTAR in November.
Yes.
Thank you.
Excellent. Thanks very much, guys. It was a great webinar. I'd just like to remind everyone that this webinar was recorded, and later next week, I suppose, we'll be sending a recording to everyone that attended, that you can look at in our archive. I actually see a question's just come in there now, Bob and Iris, if you want to handle it. Maybe we ended a little prematurely, so I'll hand it back to you guys.
Can you repeat the question? You're closer to it.
I will repeat the question from the screen. Question from Graham Thomas. How do you overcome the perception that Six Sigma is about 3.4 defects per million, therefore a very low level of defects achieved from a highly repeatable process, and the fact that Lean is also geared to repeatable volume process, whereas software testing is a less repeatable process, more of a one-off, and struggles to achieve these quality levels?
Well, I suppose you could make you can make a difference in that respect. Testing is, I think, you have parts which are more repeatable and parts which are less repeatable. Repeatable could be if you're just in a maintenance situation where you have an application and you just have whatever 4 times a year you would have a new release with a few changes. A lot of the testing you do is repeatable. A lot of the work you put in is then repeatable. So if you're smart and you align your process better, you would be able to, I don't know whether you would always have to strive for Six Sigma level 6 probably, but you can definitely make your process more efficient than you would have now. And I think from my experience, if you're at a bigger company, you would have 4 releases a year because there's such a long time in between. People forget what they've done. Or we have time enough to store it or to put it in nice version control, whatever, because we have another 4 months we have to use it again. So you forget to actually efficiently align all the steps in your test process. I agree with you that when you're working on something new, a first time off a new application you're working on, it's very hard to straight away get to Six Sigma level 6 or to whatever Six Sigma level. This maybe comes in after the new application, new part of the application gets into a more maintenance situation. Do you have something to add to that, Bob? Okay. And another question coming in, which says, which actual metrics do you use for the improvements in your project at the moment? Sorry, it was a bit long, but the letters are a bit small, and I'm the furthest away from the screen from the two of us. Well, that again is a question. What metrics myself or Bob would use at this moment doesn't necessarily have to be the metrics that you're using in your project. It depends on what you have to improve. Lean and Six Sigma actually also help you in defining the metrics or in helping you to think of which metrics would be useful for your situation, because what you want to improve, the project that you picked, might not necessarily be the one that Bob and myself have now. So you have to, metrics will always be, I suppose, and I think we heard that from in a lot of seminars that we visited over the years. It is hard enough to pick the metrics, but if you have them, start using them. I suppose that's the message that Six Sigma also holds. I can't give you a one-on-one answer on which actual metrics to use.
I'm using production failures in the first 2 weeks at the moment to see how effective our own testing was, because we just had an implementation and we are measuring service calls at the moment. That's one example. I also measured the time it took for each area of the system to define the test cases, so we know better how to estimate that in the future, things like that.
Okay.
That's the last question.
No, there's another question coming in now. If we are really successful in adopting Lean, then can you maybe read the question box again?
If we're really successful in adopting Lean, then in essence we reduce the need for testing. After all, defects are waste. What are your thoughts on the demise of testing?
Well, I suppose that's a good one. What Lean and Six Sigma both tell you is look at the customer, and I suppose the message behind it is the process, every step in the process has to add value. And the discussion would be not can we get rid of all the defects, but I suppose what value do we add as testing or with testing. We know we cannot test everything. We all know Dorothy Graham's slides, and where we were testing for 17, 18 years for a small change. So we can do that, but we have to look at what value does testing add. So I suppose it's not only about finding defects, but maybe also about telling what the quality of the system is. So I don't think that testing will necessarily be obsolete or something like that after a while.
Yeah. Well, I have in addition to that, because I think systems will be getting more complex and there will be more systems built. So I think it's good that we do it more efficient and effective, because well, there are not enough testers to cope with that otherwise. So it's good that we make a more efficient process, and we still have a job. That's it then.
Okay, I don't see any questions coming in anymore now. Okay, thank you again then for listening to this webinar.
Excellent, guys. I think that's it for today. A lot of very interesting questions there.
Yeah.
I suppose this time we really are finished, so I'd like to thank Bob and Iris for the great webinar. And just to remind everyone attending, as I said before, that this webinar is recorded and we should have a version available in our archive over the coming days or weeks. And also that this is the EuroSTAR webinar week. So if you go to the website, there's another 5 webinars taking place from tomorrow onwards until the end of the week. So maybe there's something there you might like to attend later in the week. Again, thanks to Bob and Iris, and I just remind everyone to log off and to hang up their telephones because this webinar is now complete. Thanks a lot for attending. Bye.
Bye.